Okay, so it's a little half sheet. Gonna be a fairly quick one. So on part 2, it's interpreting rates of change, reading the story in the slope. Okay, this is the important part because a big part of algebra 2 is can you interpret scenarios, right? Not can you just say, oh, that's a positive, that's a negative. Well, what does that mean in terms of the problem? What is a positive? What is a negative? What are you analyzing? Okay. A key concept here is that the steepness, aka your slope of a line segment on a graph, tells us how quickly one quantity is changing compared to another quantity, right? So if I have a really steep slope, that means my y values are growing pretty fast compared to my x values as my x values increase, okay? So we're going to look at a real world example. And we're going to talk about that real world example. So if you look up here, we have time versus value of some sort, right? So when you are looking at this, we should be able to define each one of these rates of change. Does that make sense? So we should all be confident and able to find each one of these rates of change. So when I look here and I look here, and I'm finding the change in y and change in x of this line, I am looking for change in y or change in x. So where it says you're steep upward, that's going to be where this is an increase, correct? We agree? So this is where we're talking about that steep upward. So to find it, I'm going to analyze the value. So we're at 0, 0, and we end at 2, 4, in case you can't see it in your notes because it's kind of tiny. Okay, because I have those values, could I find the steep upward slope? Yes, because our rate of change equals
What's the one in the middle say?
Increase. Yeah, I respect that. I'm telling you, it's like today I forgot how to write. Okay, so to find our change in y over change in x, that's basically just your what if you're looking at a graph. Cute little saying, rise over run. It's just essentially your rise over run. So our rate of change for our positive, our increase would be our rise. We went up 40, right? We ran 2, so it would equal 20. Okay? When you are interpreting what this means from a graph, that means that you are identifying what's your y, what's your x. Because remember, it's change in y over change in x, right? And our change in y was the value over the time. That's what our y and our x represent. So this would be 20, whatever the value, this is intentional, / whatever the time. Yeah. Is it a 4.0? Oh, y'all got way better eyes than me. I never saw the decimal, guys. Look at y'all with those young eyes. Good job. So it's 2 point, not 20. So it'd be 2. So it's our values are changing by 2 values for every measurement of time, right? So when you are writing your units, you must pay attention. What is your y representing? What is your x representing? Because it's going to be delta y over delta x, exactly the same for the units. Okay? All right, our horizontal. Where does our horizontal happen from? Horizontal starts at starts at 2, and then it ends at 4. So when you have a horizontal, sorry, trying to erase. I need to write 4.0 twice. All you're doing is measuring how much did you move over, right? So I went from, yeah. And because it's a straight line, I'm on a treadmill and I'm not on an incline. So what is my horizontal measurement right there? What does the treadmill say if you're not on an incline? 0, right? The reason why we know it's going to be 0 is because it's our change in y over our change in x. Our change in y has no change. I am still at 4.4 and 4.0 and 4.0. Okay, so I end up with 0 in the numerator and then 2 in the denominator, and anything divided by is 0. Okay, so anytime you have a horizontal line, it represents no change, and it's just going to be constant over that time. So it's going to be constant, just 0, no change. We're on a treadmill with no incline. Okay, remember in life, it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. Okay. All right. Our last interval that we got to be able to analyze is finding a downward slope interval. Do we have evidence of a downward slope here? Yes, it starts here at 4,40, and it ends here at 2.0. Okay. Can I find the rate of change here? Yes, it's your change in y, your change in x. So I went from 4.0 down to 0. What is that? I went down, right? So I'm going down. So that makes it's going to be a negative 4.4. And then I went to the right 2 units. So that's going to give me negative 2.2, negative 2 and 2/10. And again, I'm going to put my units. My units are my change in my y. And my change in my y is the value over my change in my x, which is the time. So this is negative 2 value per time. I don't know. What did I write? Oh my goodness. It's called sleep deprivation. I have not been asleep since yesterday morning when I woke up. Okay? Easy enough? Again, when we're identifying the units, it's our y over our x, our y per our x. Our units are our y per our x, okay? So in case you need to remind yourself, units equals your y per your x. Okay, questions about part 2?